by the brakes is equals to 40,000 joules. Then time within which this work is done is 5 seconds. Then we are asked to calculate the power of the brakes, and the power is defined as work done over time. So we now see that power is equals to work done 40,000 joules over 5 seconds. So this is also equivalent to 8,000 watts. So the power is 8,000 watts. The power of the brakes is 8,000 watts. Welcome to today's online tutorial. In today's lesson, we are going to be solving questions from the topic work, energy, and power. Remember that in the previous video, we discussed the topic and how to derive different formulas for this topic. So let's take question 1. Question 1 is being shown on the screen. Let's read the question together. A wheelbarrow is loaded with 3 cans, each containing 25 kilograms of water. If the barrow is lifted at an angle of 60 degrees and the man has moved 5 meters, calculate A, wasted effort, B, useful force applied, and C, work done in moving the barrow. For us to answer the question, we'll start by writing out the parameters that are given. We are given that the mass of the 3 cans M is 3 times 25, because each can contains 25 kilograms of water. So that is to say that the total mass now is 75 kg. Then the angle of inclination, say the barrow was lifted at angle 60 degree to the horizontal. Then the man moved how many meters? Distance S is 5 meters. So we'll take the first A, wasted effort, we can divide this into 2 to help us solve A and B. So A, wasted effort. So wasted effort is equals to Fy, and Fy is F sine theta. So in the previous video we did resolution of a vector into 2 components, the y component and the s component. So we can possibly write that wasted effort E WE is equals to this F here. This deal with this F. F here is weight of the 3 cans represent the force sine theta, and this wasted effort is equals to what is weight? Weight is mg sine theta. So we can now substitute all the parameters here. We now have that wasted effort is equals to mass 75 kg multiplied by g is acceleration due to gravity. Whether it is given or not given in any question, it is usually equal to 10 meters per second square. Then multiply by sine 60. So we are going to see that wasted effort is equals to 750, that's 75 times 10, 750 times sine 60, 0.8660. So wasted effort is equals to 750 multiplied by 0.8660. We give you 649.5 Newton. So this is wasted effort. So we are going to look at B. B says to calculate the useful force. So useful force UF is equals to Fx, and Fx is F sine, so the useful force in this case is Fx, and Fx is equals to F cos theta, which is the force in the horizontal direction, because the man is meant to move the barrel on the horizontal floor and not to carry the barrel up. So therefore, we can now write that useful force is equals to this F represents the weight which we've treated before. So we can just write it as mg cos theta. We have already resolved it here to get that wasted effort is equals to mg sin theta. So here, useful force will now be mg cos theta. Therefore, it will be equals to, this is 20, weight, mass is 75 kg times 10 meter per second square times cos 60. So in that case, we are going to have that UF is equals to 750 times 0.5. So UF will be equals to 750 times 0.5 will give you 375 Newton. So this is useful force applied. So the force that actually did the work, the force used in pushing the barrel, is actually Fx, and it is equals to 375 Newton. Then we can now calculate the work done. The work done is equals to force doing the work and the distance moved. So Fx times x, you understand? Fx is the force that is dragging the barrel on the horizontal floor. S is the distance the barrel traveled, the distance the man moved with the barrel. So this is going to be equals to Fx 375 Newton times 5 meters. So now have this is equals to 375 multiplied by 5 will give you 1,875. 1,875 joules. So you now have that the work done is 1,875 joules. So we have answered the three questions. Remember, the first question is calculate wasted effort, and wasted effort is the same as force in the y direction, and force in y direction can be expressed as mg sin theta. Then useful force is force in x direction, and force in x direction is the same thing as mg cos theta. Then work done is Fx, the force doing the work, multiplied by the distance moved by the barrel, which is 375 Newton times 5 meters. So we'll go to the next question. We are going to question number 2 now. Question number 2 is being displayed on the screen. So let's read the question together. A boy of mass 30 kg climbs a coconut tree of height 5 meters. Calculate the work done by the boy. So we are asked to calculate the work done by the boy. The first thing we are going to do is, as usual, we'll write solution, then write the parameters. Mass of the boy mass of the boy is 30 kg. The boy climbs a coconut tree, and the height of the coconut tree is 5 meters. Height 5 meters. So, what is the work done by the boy? Work done by this boy is equal to the potential energy, and it is equal to mgh. So, work done by the boy is equivalent to the potential energy possessed by the boy when the boy gets to that height of 5 meters. So, we can now say that the work done is equals to mgh, mass 30 kilogram. G, remember, is 10, usually 10, except in a case where it is given to you. Usually 10 meter per second square multiplied by height. Height is given 5 meters. So work done by the boy is equals to 30 times 10, 300. 300 times 5 will give you 1,500. So 1,500 joules. So work done by the boy is 1,500 joules. So we'll go to the next question. This one is very simple. So we'll go over to question number 3. Question 3 is displayed on the screen. So let's read it. A stone of mass 50 kg is released from a height of 10 meters. Calculate A, the kinetic energy of the stone halfway during the fall. B, velocity of the stone just before hitting the ground. So, for us to answer the question, we'll write out the parameters. Write out the given parameters in this question. So we'll write the parameters in the question. Solution. Mass of the stone is equals to 50 kg. Then the stone is released from a height of 10 meters. Then we are asked to calculate the kinetic energy halfway. So at halfway, h will be 5 meters. Small h represents the height at halfway during the fall. So as the object is dropping from 10 meters, once you get to half of 10 meters, the height becomes 5 meters. So it is at this point you're asked to calculate the kinetic energy. So we'll take the first A, says calculate kinetic energy. Kinetic energy. Now, for us to find this kinetic energy, we are going to note that the kinetic energy of the stone as it falls at halfway must be equal to PE at 5 meters. We are saying that potential energy of the stone, I'm saying that the kinetic energy of the stone halfway is going to be equal to the potential energy of the stone at 5 meters. So that is to say that KE is equals to PE and PE is equals to mg. 5 meters, that small h at height 5 meters. So we have that kinetic energy then is equals to, what is the mass? 50 kg. What is g? Acceleration due to gravity, 10 meters per second square. What is the height? 5 meters. So we now say the kinetic energy of the stone halfway. This times this will give you 50 times 10, 500. 500 times 5 gives you 2,500 joules. So it means that kinetic energy of the stone as it falls halfway is 2,500 joules, and this is also the potential energy at 5 meters. So now we'll answer that of B. The B says we should find the velocity of the stone just before hitting the ground. So we have to find velocity. Now, before the stone hits the ground, there is a very important law we are going to make use of, and that law is law of conservation of mechanical energy. And that law states that energy can be transformed from one form to another. So what it implies is that when the object is at its maximum height, the energy possessed by the object by this stone at this 10 meters is all what? Potential, no kinetic energy, because the object has not started falling. But the moment the object begins to fall, the potential energy of the stone is converted to kinetic. But before hitting the ground, all the potential energy must have been converted to what? Kinetic. So we are going to say that kinetic energy which the stone is going to use in hitting the ground must be equal to potential energy at 10 meters. So we can write that 1 over 2 mv squared is equals to mg, this big H. M here cancel M. So I now have 1 over 2 v squared is equals to G is 10 particle squared times 10 meters. So we now have that V squared is 2 times 10 times 10. So V is square root of 200. If you take the solid form of it, is 10 root 2 meter per seconds, or you can just raise your calculator once and it becomes 14.14 meter per seconds. So this is the velocity with which the stone hits the ground. So, and this is the highest velocity of the stone as it falls from this height. I hope it is very clear. If you have any question on this, please do well to drop your question at the comment section, and it will be attended to. So we'll go over to the next question now. So let's go to question number 4. Question number 4 is being displayed on the screen. So let's read the question together. How much work is done by gravity if a 50 kg block is pushed along a 40-meter track? So you can see the question says, how much work is done by gravity if a 50 kg block is pushed along a 40-meter track? So we are going to write the parameters. After writing the parameters, we will now answer the question. So solution. The parameters in the question is mass. The mass is 50 kg, and the distance moved, which is along the track distance, is 40 meters. And they're asked to calculate the work done by gravity. So work done by gravity is equal to potential energy. Take note, anytime you're asked to calculate work done by gravity or work done against gravity, both of them represent potential energy. So potential energy is given by mgh. So we can find out what is the work done. So the work done by gravity is going to be mass 50 kg multiplied by g 10 meter per second square. Then height. Remember, he said this object was dragged on the floor on 40 meter track. 40 meter track. So this is distance and not height. So we can see the height here in the question is 0. No height is given because the mass is not being lifted up. Assuming that this 50 kg is being lifted up, then we will now say that work is being done against gravity, or if it is falling from a particular height. But here, was just being dragged on the, since it is just being dragged on the horizontal track, the height there is 0. So if we put 0 here, meters, it means that work done by gravity automatically is 0 joule. So no work is done by gravity in this case. There is no work done by gravity here. For work to be done by gravity, the object is either being lifted up or is falling from a given height. So we'll go to next question. So we'll go over to question number 5 now. So the fifth question, the question is being displayed on the screen. So let's read the question together. When a car stops, 40,000 joules of work is done by the brakes in a time of 5 seconds. Calculate the power of the brakes. So solution, write the parameters. The parameters are that work done by the brakes is equals to 40,000 joules. Then time within which this work is done is 5 seconds. Then we are asked to calculate the power of the brakes, and the power is defined as work done over time. So we now see that power is equals to work done 40,000 joules over 5 seconds. So this is also equivalent to 8,000 watts. So the power is 8,000 watts. The power of the brakes is 8,000 watts. So please, if this is the first time you are watching my video on YouTube, please do well to like the video, subscribe, please share the video with your friends so that you get to many students.